Hello viewers and my dear students, welcome to session 9 on projection of solids demo. We are touching upon hexagonal pyramid. In fact, we have already started and we have finished 2 sessions on hexagonal pyramid, and this is the third session on hexagonal pyramid demo using solid edge. See here, we were at this stage earlier. Now you see here, this here, this is a hexagonal pyramid in corner position. I got the top view, I got the front view. I have told you already. Okay. And then I have tilted completely right so that it is O dash D dash on XY line. That means it is a slant edge OD on HP. Okay. What I'll do is I'll remove this. I'll put this only. Okay. This is O dash and this is O1 dash. This is axis. Okay. It is slant edge O dash D dash on XY line. Okay. That means it is a slant edge on HP. For this, what I've done is, first step is I completed the outer boundary. Okay. And then the second step, when you're looking from the top, base is nearer than the apex. That is, base is seen by the observer. I have darkened the base. Now count the number of edges. 6 plus 2, 8 edges are over. You're still left with 4 more edges. Okay. When you're looking from the top, OA you see here. OA is the nearest edge. What you can darken it. Okay. This is OA, darken it. And there is OD also. OD is the edge on which it is resting. It is blocked by the solid. OD you cannot see. You have to make it dark dotted. Then when you are looking from that, comparatively this OC and OE edges, when we are looking from the top, it is blocked by the solid. As a result, OC and OE also will be invisible. You should make it dark dotted. Okay, now first OA, 4 edges. First OA you see. OA you take. Okay, OA you take 0.5. From here, end point to end point, you darken it. Okay. Is it okay? Then OA, then you see here, O to D is invisible. O to D, because it's on the edge on which it is resting. When you're looking from the top, OD cannot be seen. OD cannot be seen, but OD is invisible, but it is merged with visible edge OA. Up to A it is merged. That is why invisible edge OD can be seen only between A and D. That is why what I'll do is, only between A and D, I'll make it invisible. That's why what I'll do immediately before we forget, I'll take this and compulsorily you take this only. Dot dotted. This is invisible edge representation. Okay. In that way, now 6, 7, 8, 6, OF, OA, OB and OD. 10 edges OA, over. Then OE and OC. And when you're looking from the top, back corner edges, okay, make it dot dotted. That is invisible. In that way, again, you see here, you take this 50.5. Okay, you can even directly take this also. And okay, from the end of this to end of this, you do this correctly. And from the end of this to end of this, you do this correctly. In that way, you have done correctly. Okay. Then as you see here, you have done everything except you have not shown the axis. Okay. What I'll do, I'll show the axis also. Axis is O1 point. And you see here, O to O1. This is axis point. Okay. This you show. It will be completed in all respects. But axis you can't show it here because here you have shown axis. No. This type of axis you can't show it here because you have one invisible edge running and also visible edge running in axis. This is O to O1. That's why O1 point you show, because O to A you have visible edge and A to O1 you have invisible edge. You are always preferring visible or visible and invisible edges over the axis. Axis is not an edge. That is why unless it is exposed like this, okay, don't show axis. Only the axis point you show. Okay, now you have done this Okay, that means slant edge on HP. For this, when you're looking from the top, this is how it appears. Now you see, whatever may be the problem given, you see. Now if you understand after this stage, now it is slant edge on HP. When this pyramid, when the hexagonal pyramid is on slant edge on HP, this is how it appears. Okay, when you are looking from the top, this is how it. If they say slant edge on HP, slant edge on HP is OD, correct? No, this OD, since it is on HP, what I did, this it is, since it is on HP, this OD is in true length. If I say slant edge on HP inclined at 45 degrees to VP means it is a true length only. Directly make OD inclined at 45 degrees to XY line and complete the problem. Did you follow? If I say, see here, please understand these things are. If I say this O over 1, this axis, no? Axis parallel to profile plane means you make O over 1 perpendicular to XY line. Because profile plane is here, once it is parallel to x1, y1, it is parallel to profile plane. That is why if they say axis parallel to profile plane, you make O over 1 perpendicular to xy line. So that O over 1 is parallel to x1, y1. If they say axis parallel to profile plane with apex touching VP means put O on xy line. Okay. In the same way, if they say axis parallel to profile plane, that means O1 perpendicular to xy line. If they say axis parallel to profile plane with a corner of the base touching VP means make O1 perpendicular to xy line, D on xy line. In that way, you can make so many changes. But here, we'll see what exactly is the problem, what they have given here. Here, draw the projections of the hexagonal pyramid in this position when base is nearer to the observer as one of its slant edges on HP with the top view of the axis inclined at 45 degrees to VP. Okay, when it is top view of the axis inclined at 45 degrees to VP, you have to O over 1 is the top view of the axis. See here, O over 1 is inclined. This is true length. This O over 1 is the top view of the axis. The top view of the axis should be inclined at 45 and the base should be nearer. Okay. For that, what you have to do is, see carefully. See, I'll take move. I'll take the entire thing. Okay, I take the entire thing. And copy is also required, no? Copy also is required. With reference to an endpoint, I'll move it here. Okay, then put escape. Okay, now once you do this, okay, once you do this, you see here, there is rotate command also. Rotate. Your top view of the axis should be inclined at 45 degrees. O1 should be inclined at 45. Don't move O this way. If you move O this way, apex will be nearer. Move O the other way only, so that base should be nearer. Since it is slant edge on HP and you are tilting about the slant edge, the top view remains same. Okay, because it is already resting on HP. Keeping resting on HP constant, I am rotating the solid in such a way that the top view of the axis is inclined at 45 degrees to VP. Okay, base is nearer. Now I'll take rotate command. I'll take this entire thing. Okay, and I'll take the end point here as the fixed point, and I'll take the end point here as the moving point. I'll take 45 degree rotation angle, 45 degree I'll take. Okay, now it is over. Now you see here, once you've done this, see here, even if you see here, this is, you always observe, it is, you take care of this parallel line. Can you understand? If you take this parallel line, otherwise also, you take any line like this, okay, it is actually, and you have collinear, no? Okay, you take this collinear, you see here, take collinear, you fix this, you fix, okay, you touch that, it will be in line with that. This is actually point, I'll take a continuous line. Okay, now it is over. Okay, the extra thing and all that, you trim it off. Extra line and all, extra thing, you trim it off. Now you see whether it is 45 degrees to VP. Okay, it should be inclined at, It is perfect now. It is inclined at 45 degrees to VP. Top view of the axis is inclined at 45 degrees to VP. Or slant edge on HP is inclined at 45 degrees to VP. Both are same because slant edge is inclined at 45 degrees to VP means it is the OD is already in true length there. That is slant edge on HP inclined at 45 degrees to VP is same as top view of the axis because this is reduced length O1. Okay, top view of the axis inclined at 45 degrees to VP, both are same. Okay, in that way, you complete this. This move, copy, rotate in such a way this 45 degree. Now you go for this line. Okay, all 0.13 line. Okay, projector lines. See here, this I have taken this. You make it as a continuous line. Okay. Okay, everything you make it as continuous line by pressing the control command. No, control pressing control. You see that it's a continuous line here, and these things work. Okay, you got the projectors and all that. Now you take the projectors from here also. From E, take a projector from E. Take a projector from F also. Take a projector from A also. Take a projector from D also. Take a projector from B also. Always sense the endpoint and all that. Be careful. Take a projector from C also. Okay, if you have taken the projectors from all this, okay, you got the projectors here, and you see here, you got the projectors and all that. Now you see that as far as possible, see this extra things and all that will trim it off because otherwise sensing will be difficult. Okay. Okay. Now you see here. Now this you enlarge it. You enlarge it. Okay. Now you is get better. You do this. Okay. Slowly you take this. On this point you should get O. Okay, go for the intersection. On this, A, no, carefully see, A should be in this line, correct, no? A is here, okay, we'll name all that. Then F should be on this. Okay, you have to wait till intersection comes up. Then B should be on this. Okay, you got intersection, you pick that. And C and E. Okay, E point is here. And I think C point is here. Okay, C point is here. Then D point you see, D point is here. Okay. Now, once you have, see 6 points I have, O point is also you have. We'll go by the procedure. We'll first complete the outer boundary. Since first step is outer boundary is completed, then we'll since base is nearer, we'll darken the base. In that way, we'll complete all this in the next session. Please follow the next session, that is session number 10, for understanding the remaining things. Okay, now we have come to the end of session 9. Thank you very much for watching. Thank you, friends. Thank you.